So Dr. Bencheriet received a PhD degree in signal processing from the LAIG of the University of Annaba, Algeria, in 2007. She is currently senior lecturer class A at the Computer Science Department in 1945, University of Guelma, Algeria. Actually, she's the president of the scientific committee in the Computer Science Department. She's author of over 50 peer-reviewed scientific publications and conference papers, and contributes in the 8 national and international research projects in different fields. An author of books entitled Detection at Recognizing Devices, the Importance, Test Characteristics, Geometrics, Fascination, a Day, Collar Day Pro, edited by UAE in 2012, and Courage at Representation DEI Information, edited by OPUC in 2015. She participated as a member of program and organizing committee in more than 20 national and international conferences, and contributed as a reviewer in renowned journals such as IET Computer Vision, IET Biometrics, IET Image Processing, IET Electronic Letter, IEEE Access Journal, the Visual Computer Journal Springer. Her research interests include machine and deep learning, face detection and deepfake detection, intelligent transportation system, vehicle detection, and tracking classification of remote sensing, etc. So we are very happy to have you, ma'am, in the presence. And our expert is going to give a talk on challenge of deep learning in fake face detection. Over to you, ma'am.
Okay, thank you very much. Did you see my screen?
You're audible, ma'am. You're audible.
Can you see my screen?
Yes, madam. Yes, madam.
Okay, thank you very much. Thank you for your invitation.
Yes, madam. Please share your screen.
You can see my screen? Okay.
Yeah, ma'am. It is visible, ma'am.
Okay. Hello, everybody. I'm Dr. Bencheriet from Algeria. I'm a lecturer in the Computer Science Department at the University of Guelma. I mainly work on artificial intelligence, machine learning, deep learning, applied in pattern recognition, intelligent transport system, and security. This day I will present my present challenge of deep neural network in fake face detection. Mainly the plan I will present, the plan is the introduction, problematic, state of the art, and conclusion. I start my presentation by asking you, can you determine which are true and which are false images from all these images? Human cannot distinguish between synthetic faces and original or real faces. Synthetic faces generation has overgrown over the past few years, creating hyper-realistic forged images and videos based on deepfake techniques. For example, in all these images, we can't discern between real or fake images. Of course, no one of these or all images are realistic. This is one of the famous video in the famous video of President Obama, a video in which abusive languages about Donald Trump is put in the mouth of Barack Obama, has been viewed nearly 3 million times. State of the art. Deep learning has been rapidly developing, creating new technologies, including deepfakes that becomes popular due to the massive availability of images and videos in social content. Deepfakes can treat towards security when deepfake procedures can be employed to make videos of world leaders with forged speeches for false purpose, abused to cause political or religious misunderstanding between countries to fool the public and affect the result in election campaigns. The deepfakes can create confusion in financial markets by creating fake news and create forged satellite broadcasting images of the Earth to hold items that do not exist to create chaos in the military. Other deepfakes can share doctorate footage of people. The problematic here is that deepfakes is considered to be one of the most dangerous uses of IE, artificial intelligence. So most of its real-world applications have either discrediting of fraudulent intention, difficult of or even possible task for human beings to do. The machine managed to receive human visual ability. It is therefore important to find or design tools or application to discern fake face from real ones. Use the same tools that created the deepfakes, deep neural networks, or DNA. State-of-the-art work on forgery detection is divided into the main objective. Before this, the main objective take an overview of the method using deep learning for the detection of fakes. State-of-the-art work on forgery detection is divided into two categories: fake image detection and fake video detection. The work on the detection of fakes on videos are also divided into works based on analysis of biological signal and other which analyze spatial temporal signals. So, state of the art of fake images, we divide the state of the art of fake images into 4 categories. The first one is work about neural network-based method to detect fake gun images using pre-processing techniques to analyze the statistical characteristics of the images and improves the detection of false face images created by humans. The second one is the model using deep learning network to extract facial features based on facial recognition networks. Then a fine-tuning step is used to make the facial feature suitable for real fake images detection. And the third one was a convolutional neural network, CNN, that applied to stages of images pre-processing, Gaussian blur, and Gaussian noise to neglect low-level high-frequency Q artifacts in GAN images and improve low-level pixel statistics. This allows the classifier to learn more meaningful features from real and fake images. before the last one is network has two streams. Phase classification streams is used on GoogleNet datasets to train the model on fake and genuine images. Then the patch triple stream is used to analyze the feature using stig analysis feature extractor. So a two-stream in this image, in this figure, you can see that a two-stream network to detect phase alternation. The phase classification stream is used to on GoogleNet to train the model on falsified and genuine images. Then the touch triple stream is used to analyze feature using the SIG analysis feature extractor and captures low-level camera features and local noise residual. The method explained here in this figure is the method consider eye blink to detect fake videos, which is an important physical characteristic that can be used to distinguish fake videos. To achieve this method, use a convolutional neural network with a recursive neural network element to discover physical signals such as eye movement and blinking. Then the model uses a binary classifier to detect the state of closed, and open eyes. This approach is tested with a dataset called Eye Blinking Explored from the Internet. Eye blink datasets are the first available datasets designed specially for eye blink detection. The result of experiments demonstrate the effectiveness of the suggested approach in detecting false images. Other biological signals such as hair rate have proven to be a reliable predictor for actual video. For example, designed a model based on the generative adversarial network GAN that can detect deepfake video source by analyzing the heartbeat of deepfakes. The proposed model starts by having multiple detector array, where the input to this model is the actual video. Then the pair of realistic videos and fake videos is assigned to another layer called registration, which extracts facial region of interest and biological signal to create PPG cells. Here, the PPG cells are spatiotemporal windows that contain multiple faces extracted using a face detector. The last layer is responsible for classifying the video as fake or real. Here is a figure explain all these steps. In this work, Mittal and al. Developed a deep learning framework to detect deepfakes in multiple media, multimedia. The main objective of this model is to understand and examine the interaction of audio speech Now here, excuse me, here is the author introduced the time-sensitive model to detect deepfake video. The model is first use convolutional neural network CNN for frame feature extraction, then this feature are passed to the LSTM layer to analyze the control sequence of phase manipulation between frames, and finally a soft max function is used to classify video as real or fake. This is some important paper, some other important paper here. In this paper, the following main contribution: publicly available database of low and high quality sets of video from legitimate databases with swiped faces using GAN-based approaches. Vulnerability analysis of VGG and FaceNet-based face recognition system, and evaluation of several detection methods of deepfakes, including lips sensing and approach and image quality metrics and SVM method. This is another important paper about deepfake detection approach using deep learning, systematic review. In this paper, the author have classified work on deepfake in detection on images and videos. Work on video have been categorized into visual artifacts within frame, artifact within frame, and temporal features across frames. Video artifacts within frame is shaded into two parts, shallow classifier and deep classifier. They compared 5 of the best applications as well as the tool used to the detection of fake as represented in the following table. As example, in the first one, the tool is Deepfaker. Algorithm used is GAN with the scene. Key feature reconstruction of face is done by DSSEM loss function and chaos library based implementation. In the second one, face swap GAN, the algorithm is the network GAN version 2.2 with MTCCR. The key feature is the autoencoder architecture is provided with adversarial loss and perceptual loss are added to. The third tool is face swap. The algorithm is also done with MTCCN and DFL H128. Key feature is parameters of the encoder are shared and pairs of encoder-decoder. The other one is the Deep Face Lab tools. They also use GAN with MTCS 3D TFD. Key feature is expand from the face swap model with new model uses multiple face. And the last one is deepfake TF. Algorithm used is also GAN, but with DSSEM, IM. Feature used is like the faker, but TensorFlow is used for implementation. Another important work is the fake face detection via adaptive manipulation face extraction network. Pre-processing, where the author used a pre-processing model, namely IMTN, is especially designed for CNN-based face image forensics. Integrating IMTN with CNN or robust fake face detector, namely IMTN, is constructed. Here, the architecture of IMTN explained here, and it was integrated in the CNN. And here is the fully connected layer, the last one. The author used two in dataset. They used two types of datasets. Dataset of real face images for train, of course, and the dataset of fake face images. In the first one, in the category of real face images, they use three datasets: CLAB-A HQ, and YouTube frame. In the second one, dataset fake datafaces, they used PGAN and StillGAN and Glow and face-to-face and StarGAN database. Here some important. Here I will explain. I will share with you some important data sets if you want to work on fake generation or fake detection. The most famous is Filker face data set, faces HQ data set. The data set contain a collection of 70K face images with high quality resolution generated by Generative Adversarial Network, the GAN network. The images were collected from the Filker platform and contain images with various accessories such as eyeglasses, sunglasses, hats, etc. According to the dataset author, a pre-processing step was done on to prune and remove noise from images. Another dataset and important dataset is 100K faces. Is a well-known publicly available dataset that include 100K unique human images generated using StillGAN. StillGAN was applied on a large dataset consisting on over 29K images gathered from 69 different models, generating photo with a flat background. Here is some example of dataset. Another dataset is diverse fake face dataset, DFFD, contain 100K and 200K fake images generated by adopting respective state-of-the-art method, ProGAN and StillGAN models. The dataset includes approximately 47.7% male photographs and 52.3% female images, and most of the samples range in age from 21 to 50 years old. I haven't I haven't ended a lot of time to prepare more slides, so I just set some other data sets: Casia web face, VGT phase 2, the eye blinking dataset, deepfake image dataset. If you want to work on fake detection or fake generation, you can use this dataset to compare your results or to train your deep neural network. Now we will explain some advantages, some advantages of deepfakes technology. There are an advantage of deepfake technology given its popularity worldwide. The first one is making digital voices for actors who lost theirs because of disease, recreate classic scene in movies or create new movies starring along the actors, allow for automatic and realistic voice dubbing for movies in any language. But deepfake are a lot of disadvantages, such as threats to world security when deepfake procedures can make videos or world leaders with forged speeches for fraudulent purposes, abused to cause political or religious misunderstanding between countries, to fool the public and affect results in election campaigns, creates confusion in financial markets by creating fake news, creates forged satellite broadcasting images of the earth to hold items that do not exist, and to create how in military, share doctored footage of people. In conclusion, we can conclude all this to the creation of deep fake videos can be harmful and have malicious purposes for public and private people, as it is difficult to be detected by naked eyes. Also, it becomes more accessible for amateurs use. That's why deepfake detection systems are becoming more and more obligatory to reduce spreading misinformation and misunderstanding caused by these fake videos and images. This is some reference used to prepare this presentation, and thank you for your assistance. If you have any question, please.
Thank you, madam.
Thank you very much.
Yeah, thank you, Dr. Bencheriet. Thank you so much for taking the time to speak in the conference, ma'am. Really, your insights and your perspective are truly valuable, and we are all thoroughly engaged by your presentation. It's a pleasure to have you with us. Your passion on the topic on this machine learning and deep learning and fake face detection and various domains really came through your mind and your from heart and through your words. And we're all grateful for the knowledge and inspiration you shared with us. So your contribution to the event was invaluable. And again, thank you for your time and for sharing your expertise with us. We hope to have the opportunity to work with you again in the future. Thank you once again, ma'am.
Thank you very much. And excuse me, I haven't a lot of time. You contact me 2 days. Excuse me for the presentation.
Hello,
I haven't
madam.
a lot of time. Yes, you hear me? You hear me?
Hello.
Hello, you hear me?
Technical issue.
Hello.
Ma'am, I'm audible to you?
Yes, I hear you. And you hear me?
Hello.
Hello. I'm here, sir. I'm here, sir.
Madam, I am audible.
Yes, I'm able. I'm here. I just want to inform you that I haven't a lot of time to prepare more slides and more information about fake detection and all.
Ma'am, I'm
start
audible?
the stage of the. Yes, yes, I'm here. Yes, I'm here, sir. You hear me? Yes, sir, I'm here. Yes.
చూస్తుంది. Yes, sir. Yes.
Thank you very much.
Thank you very much, madam, for your giving wonderful support to me. And this conference make a grand success. One of the threat to you. Without your concern, this thing cannot happen. Thank you very much, madam. In near future, we are continuously acquire knowledge from your end. We are planning to work together, and we are in near future we work together in national and international projects. And I need your continuous support, madam.
Yes, I hope so. Thank
Thank
you
you very
very
much,
much for. Thank you for your invitation.
ఆవిడ విన్నది. Please fill the feedback form, for it is considered for attendance for audience. Next session will be started sharp 3 o'clock. Okay. Thank you very much, Madam Nahara, madam. Thank you very much. Can I close the session? Ma'am, can I close the session? Okay. Thank you very much. Next session will be started sharp 3 o'clock with keynote on data production versus chart GPT. The name Professor Dr. Chamenda Havi, and this is the associate professor in data security department and Cardiff Metropolitan University, London. Shortly, we'll touch with you. Please join sharp 3 o'clock. Thank you very much.